This old porch wasn't just in rough shape, it was done. We ripped it out, filled in the hole, and rebuilt everything from scratch. Stick around as we show you the entire process of bringing this brand new porch to life. Welcome. This series of videos is all about the journey of rebuilding our porch. We're sharing it both as a story for our friends and family to look back on, and as a practical guide for anyone tackling a similar project. We're Aaron and Anna, a couple in our 30s with 2 kids, a few big projects behind us, and plenty more dreams ahead. We'd love for you to follow along as we build together. This is video number 2 of the series, covering the construction of the deck level and sidewalks. What is shown in this video happened back in 2021, so almost all the visuals are photographs from the archives. It was suggested back then that I make videos about the project, but I thought, I don't have time to waste on that. Apparently, now with 2 kids running around, I have found the time. Anyways, we start out with the demo of the old porch. At this point, we have spent a few hours tearing into the old porch with pry bars and a sawzall. This certainly wasn't the original porch. I'm going to take a wild guess and say it was redone in the 80s. Modern lumber, joists, and hanger brackets can be seen in the photo. In the bottom center are wood chip remains of a stump about 6 inches deep, and then solid remains of a stump below that. What a frustrating combination. We paused demo here for a few weeks, and the events of video 1 mostly took place during that time. Eventually, we had to lose the use of our front door and move the mailbox to its temporary home so that demolition could continue. We got a lot of good scrap lumber out of there. Revealed underneath the old porch is a big hole. The previous owner had water issues in the basement on this side of the house. I'm sure this would fill up with water during heavy rains, and then it would seep into the house. There's a brick perimeter foundation from an even earlier version of the porch, so I suppose at one time there was no dirt inside of that. In fact, our neighbor in the background there recently started completely revamping her porch, and she has a stone perimeter foundation underneath, which is completely empty of dirt still, an empty hole about 2 feet deep. That same neighbor did some grading in her backyard, and she had some extra dirt, so the skid steer that was doing that just dumped it into our hole and mostly filled it in. I had some other random dirt around the yard that I added to bring it up to a nice slope away from the house. In the middle, we can see the straight perimeter wall kind of hiding in the dirt. That was probably from the original circa 1890 porch. The 1980s porch must have added these concrete piers just outside of that brick wall. We couldn't trust the specs on them, nor feasibly dig down 48 inches on every single one to verify, so they needed to come out. You can see on the right a 12-inch concrete cylinder, maybe 4 inches thick, up on edge. It's been moved. For some reason, they also had these apparently cast in place on top of the actual pier. They seemed to be much newer concrete. Either another generation of porch was in play, or this was some sort of fix for slumping over time. I built this thing to lift out the concrete piers. I believe the most specific technical term would be GYN, G-Y-N. I love a good technical term. It has 2 main load-bearing legs, which would be the ones on the left in this photo. I cut a notch in the top of each of them and laid in a piece of cast iron pipe, which I'm sure was scrap from our radiator system rebuild. Then the chain hoist is attached to that pipe, and the 2 legs on the right are for stability mostly, just to keep it from tipping over. You can see that they are tacked on with screws, and then the ratchet strap around the top adds a good bit of strength too. Overall, this was a floppy contraption that was just strong enough in just the right way, but this meant moving it to the next location was a real process. So I would pull super hard on a concrete pier with the chain hoist, sweating profusely, even with the mechanical advantage. And eventually the old pier would break pretty far down, and out of the ground would come this huge piece of concrete. After lifting it up above ground level, then I would slide boards underneath and lower it onto the boards and roll it out of the way. So here we are with the old piers out and lots of new piers in. Those aren't sonotubes filled with concrete. I went a different route. The specs on what pier I would need were just crazy by the book. Something like an 18-inch diameter bearing surface was required, depending on soil hardness. So I asked the inspector if there was a typical soil hardness for the area, and he said the higher value from the chart was fine. So maybe it wasn't quite 18 inches. Anyways, I didn't quite like the idea of digging 10 holes that big down 48 inches, so I decided to go with these no-dig pier things. The ones rated for the 48-inch frost depth that I have are equivalent to 20-inch piers. Diamond Pier seems to be the leading brand name, and one of that type can be seen on the right. It has some diamond kind of facets on the concrete, hence the name. The one in the middle is what Menards has. Handy Pier is the name. Those are what I mostly use, and I would not recommend them. I had several of them crack when jackhammering in the metal poles. I think the poles were rough surfaced, the holes were gunky and are out of spec, and the concrete was weak. It was painful to see them crack. $150 goes poof, and it has to be redone. I ended up getting a few of the Diamond Pier ones as replacements, and they were worth the higher price. Anyways, these things have been around a while and have all the building code compliance checkboxes. It's now 4 years later as I make this video, and I haven't had any problem with mine yet. They're a bit pricey, but they save a heck of a lot of digging. A couple of these piers went in near the brick perimeter foundation, and I was able to position the legs to avoid having to take out much of that. I think only one section I had to dig down and sledgehammer it out, and there was something similar with stump remnants where I was able to dodge the roots. If I was doing holes filled with concrete, then I would have had a real situation. I highly recommend this type of pier. Additional ground cleanup included digging out these old fence posts which were embedded in a bit of concrete. I also took out all the stump wood chips, which of course were mixed with dirt. I later filtered that in a wheelbarrow. Fill the wheelbarrow with water, shovel dirt and wood in, the dirt sinks, the wood floats, rake off the chips, repeat, and pretty soon you have a wheelbarrow full of silt to dump somewhere. That worked really great. The window well is worth mentioning. I wanted to leave that and the sprinkler stuff uncovered by the new wraparound porch, so the porch has a kind of funky part that is detached from the house. This was more complicated to build and does seem kind of dumb at first glance, but I think it was the right decision overall. And with that, I was at kind of a turning point. Most groundwork was done, and we were ready to start putting in a lot of lumber. Here's the main lumber delivery. The driver first pulled into the alley, and I gave him a tip to help unload those 26-foot boards by hand, even though it's something they don't usually do. Then he parked out in the street and converted his truck into forklift mode. Using that, he picked the lumber bundle off his trailer and carefully backed through the alley to set it on the driveway. This is all pressure-treated lumber, and just what I had calculated for the deck level. Here's the happy couple with their stack of lumber. Now back to this front picture again. How about those ledger boards? Being able to get 26-foot lumber was pretty amazing. That's all one piece across the front. And it was straight. Then above the ledger board I cut the steel siding with a 3-inch cutoff tool, which was a very handy unit to have. The cut ended up being so straight and in exactly the right spot that I didn't have to put any finished trim on the bottom edge of the siding. And you can see the sill of the door there. That is a massive timber, probably 1.5 inches thick. I wanted to have the deck surface level with the top of that, and it came out absolutely perfect. In this photo, I already have the posts and beams in and am prototyping the joists. The posts, which are 6x6, have notches cut to accept the doubled up 2x beams. And then the beams are bolted to the sides of the notches. Here's an example of what the posts look like. The structural beam on the corner is not curved, just angled to the middle of the corner. The doubled up diagonal joist resting on the beam is necessary because the diagonal is serving as a beam itself. It bears the load at the ends of many other joists. And that diagonal itself needed to be substantially supported, so away from the house, of course, it rests on the main beam, but on the house end I couldn't figure out a solid way to attach it to the ledger board corner. so it needed to be supported by something from the ground on that end also. The stump remnants directly underneath made it pretty difficult to put a pier in directly under the diagonal, so I put the pier in off to the left there and ran a beam over to the pier on the far right, which was already needed due to my window well opening. So that is all a bit unconventional, but fit the situation and is plenty stout. And here's a little further to the right, where you can see the necessary beamwork for the window well situation. The idea is that since the deck isn't supported by a ledger board on the house, then it needs to be supported on both sides from the ground. So the inner posts and beams were added. By the way, the whole thing is enormously overbuilt, and only half of the roof columns or piers would have been technically required with the beam sizes I used. When the labor is free, then there tends to be more room in the budget to overbuild. Now we skip ahead a bit and have joists and a rim board, and a sneak peek of the decking picture frame. I had some experienced carpenter help for a few days, so we got this done pretty fast. Having this help revealed some problems with how I had some unconventional details of the build locked up in my mind only, and no detailed plans to go off of. The first problem that came up was with the Z-flashing over the ledger board. It was about an 1/8 inch thick and pretty much extended only over the ledger board, but wasn't in place at the time. So the joists needed to be proud of the ledger by about an 1/8 inch. When 90% of the joists got attached flush with the ledger, then we had to go back and redo them all. Another issue was that I planned to keep things super flat by sorting the joists by thickness and putting them on in that sorted order. Technically, this would introduce a very small twist on the whole deck surface, as the beam end lost about a 1/2 inch, but the ledger side stayed straight. Anyways, the joists got thrown up without sorting, and an electric planer made easy work of any outliers. And lastly, the piers were not closely positioned with regards to their distance from the house. I just made sure that they were in a straight line. So the beam on top of the piers was closer to the house on one end, I think by about 4 inches. So that was enough to matter, but not noticeable. A few joists got trimmed relative to the face of the beam before I pointed this out. Fortunately, there was enough length remaining to retrim them relative to the house instead. So no lasting harm was done by these missteps, and we had a couple great days of progress. It was really taking shape. One major design change that we made during this time was to switch from the planned 16-inch joist spacing to 12-inch because the decking came in 1-foot length variations, and then we would have less waste. The 5/4 hardwood boards, 1-inch actual thickness, had a max allowed span of 24 inches, so I was already reasonably overbuilding with the planned 16-inch spacing, and at 12-inch it is super stout. Where the top of the posts are visible, you can see that there's something black on them. This is joist tape that I put on, which should prevent water from getting into the end grain of that 6x6 for many years. I also put joist tape on top of all the joists. In the back, you can see that we had to put in another joist to catch the ends of the regular floorboards, the ones inside the picture frame, and I think we did several pieces of blocking between that extra joist and the rim joist to support the picture frame board. There's the complete framing result. The finished diagonal was tripled, I think, to better land the ends of the deck boards at the corner. There's blocking about 6 inches in from the rim board, also added on the curve after this picture was taken. I believe this blocking is a code-required thing to keep the joists from twisting under load, but it was also part of my bearing strategy for the columns. Each column was predicted to substantially bear on a joist, which was likely enough, especially with over-supported hardwood, to further distribute the load. But then there is this blocking too, which sits directly on the beam below. This rim board was the first curved piece that we did, of many to come. I believe we put in the joists first and wrapped the rim on that. The rim was cut on the backside many times with a chop saw to a depth of maybe 5/8 inch. I did one cut every inch, and the board is about 14 feet long, so it came out to something like 150 cuts. I tested my process on an old joist from the scrapped porch, and even that dry old wood bent with this technique. and with juicy new pressure-treated lumber for the real deal, it was a nice smooth bend. One non-intuitive thing about this curve is that the center point of the curve is actually inside the house. Here's a drawing to explain. First, imagine on the other end of the front of the house, the center of the column sits in about 8 inches from the edge line of the house. This allows space for the eaves and soffit to look okay against the rest of the house. So the column over here by the curve also sits in that 8 inches for symmetry. And then for overall appearance, you do want the curve to start immediately from the column. You wouldn't want a straight section and then the curve to start. So this leads to the center actually being 8 inches in from either face of the house. So now we are ready for the decking. That was supposed to be in this video too, but I guess I have a lot to share, so I'll be back soon with that in a separate video. Please like the video if you enjoyed watching, and subscribe to see these future videos, putting on the deck boards, sidewalk and stairs work, building the roof, and installing the skirting.